Okay, guys, so now we'll move on to the next part of our lesson. So we will now discuss about inverse hyperbolic functions. Okay, so inverse functions, you heard of inverse functions previously. You've done this in P3 as well, right? So what happens in inverse graph? So basically, to draw the inverse function, you reflect your original graph on the line y equal x, right? Basically, that's what we do. You reflect the graph on the line y equal x, and what happens is basically the x and y coordinates are they're gonna switch. Okay, so we are going to switch the xy coordinates and we draw the graph. Okay, guys. So the first one we are going to focus. We are going to focus on the shine x graph. Okay, so y equals shine x. So we already discussed the properties of the shine x graph in the previous part, right? So we know the how the shine x graphs, how the shine x graph look, how it looks like. We know the limits. So we've discussed all the properties. So now what I want to do is I want to draw the inverse of this graph. Okay, so I want to draw the inverse of this graph. Okay, so let's see how it's done. Okay, guys. So in order to draw the R shine X graph, okay, so the inverse of the shine X graph is what we call as the R shine X graph. Okay, so in order to show this clearly, to show the XY coordinates, how they interchange, so I will simulate this on Excel and show you guys. So at the end of the day, you only need to remember the shape, okay? You only need to remember the shape and the properties of the graph. But now they've directly given you the graph, so I'll show you how it actually comes like that. Okay, so this is how it works. So I'm actually taking the I'm just generating a few x values here. Okay, so because I'm drawing the sine graph first. Okay, the shine graph. Okay, so I'm taking a few coordinates. Okay, I'm taking a few x coordinates, and you remember the I'm going to first generate the shine x equation. So you know shine x is ex minus e to the power minus x divided by 2, right, guys? So here e is exponential. Exponential and then the x value here is you give here I give my x value is -4, so ex minus, so again exponential and minus x, so ex minus e to the power minus x, and then I close the bracket to to give the numerator, so this is the numerator, close it with another bracket, divide by 2. Okay, guys. Okay, so this is my shine x, the first value, and then I just drag this down and I get the y values for the remaining x value. Okay, guys. And then I'll draw the shine x graph. And then we go to insert and we go to the chart. And guys, here you can see I have my shine x graph. All right, guys. So this is how you draw the shine x graph. Okay, so now you know the priority of this. What the point of doing this is we want to draw the inverse graph, right? So what's the inverse graph? The inverse graph is the R shine x graph. Okay, so that's what the name is. We name it as R shine x. So I want to draw the inverse of it. So guys, how do I draw the inverse of this graph? So basically, I need to exchange the x and y coordinates. Are you with me? So I need to now the y coordinates need to become x and the x coordinates need to become y. Okay, so let's do that. So I'm going to draw the graph of y equal r shine x. All right, guys. So I'm going to draw the r shine x. So you know the rule, as I told you, x and y coordinates they just need to switch. Okay, so when I'm trying to switch it, you can see I'm going to take these y values. Okay, and I'm going to copy them. Okay, I copied the x values, the y values, and then when I give it over here, so I'm going to create a new column for x. But over here, guys, if you just give the paste, the thing here is that you have a formula here, right? So it's inputting the value over here. So you can't just give control V, it doesn't work like that. You have to give for a special type of paste. So let me copy this again. So you have to give the paste values only. So I come over here and we go for the paste special and you give values. All right. So you have to just give only the values. Okay. So then you get the values coming over here properly. And then X values, of course, they don't have any formatting. There's no equation. So you can just copy paste it. All right, guys. Okay. So now I have my XY coordinates exchanged. So now it's time to draw the graph. Okay. So let's draw the graph. All right, guys. So this is the graph. The graph of give the title. This is y equal r shine. All right, guys. Okay, all right, guys. So now looking at these graphs, now actually what I want to do is I want to show you the difference between the shine and the R shine graph. So looking at this, you might it kind of like it looks a little bit similar, but you can see the axis how they are changing. So let me draw them both in one. So I'll select the all of these points together. Okay, and let's go for the graphs. And I'm going to go for more graphs and we'll go for the recommended. And you can see here that they've got both of these two graphs together. Okay, so here you've got both the graphs together. All right, guys. So here this is the combination of the two graphs together, and here you can see the clear difference between the shine and the R shine. So guys, here the shine X is the one that you can see here in blue, and the R shine X is the one you can see here in the orange. Okay, guys. So the shine X is the one you see in blue. The R shine X is the one you see in orange, and you can clearly see how the way they are different. So here the shine X graph, a reflection on y equal x, gives you the R shine X graph. All right, guys. It's just the shape that you need to recall. Okay, so the shine X graph is more. You can see it's more steep towards the y-axis, and here this is going kind of like a little bit parallel to the x-axis. So this is how the graphs look when they are drawn together. All right, guys. All right, guys. So here they've drawn again. You can see the two graphs are drawn together here with the reflection on y equal x. So basically, when you are doing the reflection on y equal x, remember we've done this in P3, the domain and the range, they interchange, right? So basically, we discussed the domain and the range in the previous section very thoroughly, right? So you recall that over in the shine graph, we did not have any problems with the domain and range. The entire real axis was available for both the domain and the range. It was a one-to-one graph. So here taking the inverse will not make any issues. So you still have the full domain and the full range for the R shine X graph as well. All right, guys. That's the summary of the R shine X graph. So now we'll move on to the R cos X graph. Okay, so that's the inverse of the cos X graph. Okay, the inverse of the function is defined only if the function is one-to-one. So guys, you remember this, right? So you can only draw inverse graph if it's one-to-one. But if you have a many-to-one graph, so then you have an issue, right? So for cos X, the domain must be restricted in order to define an inverse. Okay, guys. So what they are doing here is, now if you recall the cos X graph, I think we went through this very thoroughly, right, guys? And I told you at that point that this cost X graph, you can clearly see this is a many to one graph because you can see many X values going for one Y value. Can you see many X going for one Y? So this is cost X is a many to one graph. But the problem here is when you're going to draw the inverse, you can't, I mean, you can only draw the inverse for one to one graph. Okay, so it needs to be a one-to-one function. So what they do here is they are going to restrict the domain of the Cauchy's graph before we go for the inverse graph, right, guys? Because otherwise the inverse graph will be one to many, and that's not a function. So we need to fix this. So what they've done here is, guys, they've deleted the set of x values here that gives the repetition. So what they've done here is this section of the graph that I'm highlighting here in red. So this part of the graph is being removed because you have the same y values are repeated on the other side. So they are removed. So the repetition is removed. All right, guys. So that's what they've done over here. Okay, so this part that is repeated is removed, and then they take only this section, and they reflect it on y equal x. And that's how they've got the R Coshex graph. Are you with me, guys? Otherwise, so I'll show you this, the simulation on Excel as well. But just to give you a heads up, the original graph looks like this, the full graph. And if you reflect, the reflected graph is going to look like this. So this is a many to one to many, which is not a function. So for this reason, they've removed this part. In order to get rid of this, they remove the other part. So basically, the rule is in order to get the inverse function, the original function has to be one to one. Okay, so the original function needs to be one to one. That's why they have removed this section of the Koch graph. All right, guys, and then after we get it into a one to one format, then we reflect and we get the inverse graph. All right, guys. So let me show you here the reflection in. Let me show you the here as well. So we're going to draw. First, I'll draw y equal cos x. Okay, we'll draw y equal cos x. So we'll go through the same set of x values. Okay, and cos x, you know the equation. So cos x is gonna be ex plus e to the power minus x, right, guys? The exponential, open a bracket to give the numerator. Okay, so ex plus e to the power minus x. And then you close the numerator with another bracket. So you give the numerator separately, the bracket divide by 2. All right, guys, ex plus e to the power minus x divided by 2. This gives you the cos x graph. All right, and then you drag this down and you get all the values. Okay, so this is your cos x graph. So you can get them together. Okay, and then you give the graph. So you can see how the graph looks like. So this is the cos x graph, right, guys? So this is y equal cos x. All right. So now let's go for the inverse graph. So how does the inverse graph look like? So you need to exchange the x and y coordinates, right, guys? So these were my x coordinates. These are my y coordinates. So guys, actually, they told us now, now you can see here clearly it's a many to one graph. So they've told us clearly that in order to draw the Cauchy graph, they actually remove the negative x coordinates, right, guys? Are you with me? So they said that they remove this section because all these negative x coordinates are a repetition. So they are removing this entire section. Are you with me? So I'll remove this entire section. Okay, so guys, you can see now the graph is limited. Can you see? So I've removed this section. So let me bring these values up. Okay, I made the graph a one-to-one function. Okay, so we have a one-to-one function here. So now let's exchange the x and y. So now I'm going to draw the y equal. Okay, so I'm going to draw y equal r cos x, or the Cauchy inverse graph. Okay, so this is y equal r cos x. So what happens here, guys? Your the x and y coordinate, the x coordinates and y coordinates are going to interchange. So I'll get these y values here. So when you copy these y values, remember they have a formula. Okay, so it has a formula in it. So when you paste here, you have to go for the paste special and paste only the values. And there you have the values. So X values don't have any formatting, right? So they will just given here. So you can get them directly and you can get the Y values, right guys? So here the XY coordinates are interchanged. So now let's draw the graphs. Let's draw the R cos X graph. So guys, this is the R cos X graph. All right, so this is the Y equal R cos X graph. Okay, so now what I want to do is I want to compare the graphs. Okay, I want to compare the cos X and the R cos X graph. Okay, guys, so let's do that. Okay, then I need to remove this space. Let me remove this space, guys. All right, guys. So in this case, I just went for a scatter plot, okay, with the two graphs. Okay, so I just went to, I just got a graph with the scatter plot. It's kind of, difficult to see the curve here for the other graph. Just because the fact, guys, you can see here that this graph, it starts making the curve by around, you can see here when the Y value is 4, it starts making the curve. But over here, you can see the cos graph. You can see how rapidly it's increasing, right, guys? So when you combine both into one, you can see here cos graph is what you have here with the orange line, and here the ash dots here show you the R cos, right, guys? So basically, the values here are a little bit small, so you can see anyway. The idea here is that okay, so you can see it clearly. I think you can clearly see it over here, right? So basically, this is the idea. Okay. So basically, the graph cos x, anyway, you remove the set of x values over here and you draw this. Okay, so you have this part and you reflect it on y equal x and you have this section over here. So this is what we are trying to show. All right, guys. All right, guys. So basically, this is what you need to know. And then again, the domain and range is so important. Okay. So as I told you, the domain of cos must be restricted in order to define an inverse. So your cos domain is only defined for the positive x values. As you saw, I removed the negative x values. Okay, and you can see the of course the range. Okay, so if you consider cos we for the cos the domain restricted domain. Okay, the restricted domain is x greater than or equal 0, and you can see your range is going to correspond to y value is greater than or equal 1, because you saw the cos the red graph is valid for y value greater than or equal 1. And then if you consider the inverse graph or the R cos x graph, guys, so you know how it works, right? The domain becomes the range and the range becomes the domain, right? So you can see for the inverse graph, the domain is going to be what? So in the blue graph, your domain, the set of x values are going to be x values greater than 1, greater than or equal to 1, right, guys? You can see here the range of the cos x becomes the domain of the R cos x. So these are some rules you've learned previously, right? And the range of the R cos x is going to be y greater than or equal 0. Very clearly, you can see it here. The blue graph is just going to get y values bigger than 0. So that you can get it, I mean, the domain and range basically exchange. All right, guys. All right, guys. Okay, so we've done discuss the R shine X and the R cos X. So now we'll go through the rest of the graphs as well. R tanh, R sech, R cos H, and R cos. So I will go through all of these graphs. Okay, so next let's go to the y equal R tanh X graph. Okay, So before directly, we can directly try to draw the graphs as well, guys. Okay, so it's actually easy to do it like that. But before going to the R tangent graph, let's first go through the tangent graph. So guys, we've already drawn the tangent graph and we know the properties of it, right? We know what happens to the graph as x reaches infinity, as x reaches infinitely large values, and when x reaches to negative infinitely large values. Right, guys? Now over here, there's something I want you to pay attention. That is something that you didn't have in the Shine and Kosh graphs. Okay, you did not have this problem, but you can see that the tangent graph passes through. You can see the original tangent graph. You have a y value of 0. Can you see, guys? Your tangent graph has a y value of 0. Now you need to recall what happens. We are trying to take the we are going to try to take the inverse, right, guys? Okay, guys. So actually, what I'll do is let me show it you from the Excel. Okay, so let me show. Basically, the XY coordinates are gonna switch, right? So these, I think you can see here. What's happening here is this point actually doesn't change, right? Because we are just going for a switch here. Okay, we are not taking the reciprocal, right? So we don't need to worry about that. Okay, so let me show you how it's done it over here, and then let's do it manually. So here tangent, so I have the x values and then the y values are going to be, guys, the equation. So it was e to the power 2x. So you need to remember the equation for tangent, right? So it was e to the power 2x minus 1 over e to the power 2x plus 1. All right, so we'll give the equation. So give a bracket for the numerator, e to the power 2x. So 2 times the x e to the power 2x minus e to the power 2x minus 1, and then you close the denominator, the numerator, and then divide by, again you open a bracket, and again it's e to the power 2x e to the power 2x plus 1. Close the bracket, e to the power 2x, close bracket, plus 1. All right, guys, and then you close the bracket for the denominator, right? So you have to give the numerator in a separate bracket, divide by the denominator in another bracket, and then you get the value. So let's take it down. All right, guys. So here we have the tangent coordinates. Now we'll draw the tangent graph. All right, guys. So here you can see this is the tangent graph. Okay, so this is the tangent graph. Clearly, you can see the asymptotes, right? So we know that y equal 1 and y equal minus 1 are the asymptotes. All right, guys. Okay, so now let's draw the tan inverse graph, the tangent inverse graph. Okay, so in order to draw the tangent inverse graph, guys, you need to exchange the x and y coordinates. Okay, so tangent inverse. Oh, it's r tangent. So xy coordinates need to switch. Okay, so the y coordinates are going to become the x coordinates now. Okay, and the x coordinates are going to become the y coordinates. All right, so let's draw the r tangent graph separately first. Let's see how it looks like, and then we can do a comparison. All right, guys, I think you can see clearly what has happened here, right? So you can clearly see now the asymptotes. Okay. So the asymptotes which were on the y-axis, okay, have now become asymptotes on the x-axis, right guys? Can you see? Because you can see previously y equal 1 and y equal minus 1 were the asymptotes. But now the asymptotes are x equal minus 1 and x equal plus 1. Can you guys see? The 0, 0 point doesn't change. But the other points you can see they have changed accordingly to go near the asymptote. All right, guys. So I think we can clearly see how the two graphs are going to work out here. So I'll draw them directly here instead of going to combine them. Let's draw them here. So the R, basically the R tangent x graph. Okay, so y equal R tangent x graph. When you draw on your sketch, it needs to look like this. So you have your asymptote. All right, guys. So your asymptotes are going to be at x equal minus 1 and x equal plus 1. Okay, so these are the two asymptotes. And your graph needs to look like this. All right, guys. So this is the R tangent x graph. This is basically how you need to show draw it, and this is how it needs to look like. And also you need to discuss about the domain and the range. By the way, now if you, I told you all previously that when you draw before drawing the graph, you need to check whether it's 1-to-1 because you can only draw the inverse for 1-to-1. And you can clearly see the tangent x graph is a 1-to-1 graph, right guys? Because 1x has only one y value. You don't have many x values going for one y, right guys? Clearly this is a 1-to-1 graph. I think you can clearly see that. So then we don't need to restrict any part of our domain. Okay, so we don't have a necessity to restrict any part of our domain here. So basically, when you draw so you can see the tangent x graph, the original tangent x graph. The domain was all x. Okay, the domain was all real numbers, and the range. You clearly saw that your range, the y values were between -1 and +1. Right, guys? I think we discussed this previously as well. So now when you go for the R tangent x graph, guys, you can see the domain and range will interchange. Now the domain of the R tangent x graph, you can clearly see the x values are going to be between -1 and +1. So that's what they write as modulus x is smaller than 1. So guys, you should know x between -1 and +1 is another way of saying modulus x is smaller than 1. So this is another way of saying x is greater than -1 and less than +1. And you know your range, the y values will have all the real numbers because you can see here that all the real numbers on the axis will come. Right, guys? So this is clear, right? So this is all you need to know about the R tangent x graph. All right, guys. So now let's go for the R set x graph. Okay, so let's go for the R set x graph. So first things first, let's go to the set x graph. So we've done the set x graph here previously, right, guys? We've drawn the set x graph. So you can see clearly here we have an issue, right? So what is the issue when it comes to the set x graph? You can clearly see it's a many-to-one function, right, guys? It's a many-to-one function because many x values. You can see here 2 x values can give you 1 y on, right, guys? Can you see? Yes, the 2 x values. You have 2 x values coming from 1 y. So you have that throughout the graph. So it's a many-to-one function. So in this case, guys, you know the rule. You have to make it 1-to-1. So how do you make it 1-to-1? You remove, we can remove the negative section of the graph. So you remove the negative section of the graph and you take this section and you reflect that on y equal x. All right, guys. So that's how you draw the R set x graph. So let's get started with that. R set x. All right, guys. So let's go for y equal R set x. Let me draw the set x graph first. So I'm going to draw the set x graph with the restricted domain. Okay, so restricted domain is going to give me only this section. Okay, so set x graph, restricted domain. Is x greater than or equal 0, right, guys? So that's the restricted domain of our set x graph. And the range, you can clearly see, guys, your range, y values are going to be what? You know, here the top value is 1. So your y values are greater than 0, less than or equal 1, because this is the asymptote. So greater than 0, smaller than or equal 1. This is the Sech x graph, right, guys? Okay, so now we need to draw y equal r Sech or the Sech inverse graph. All right, so let's draw that. So basically, you just have to reflect the graph on y equal x. All right, so I'll quickly simulate it on Excel and then we'll take the shape and draw it here and we'll discuss the properties, right? Okay. So we already have the Sech x graph, which we did previously, right, guys? Yeah, so I've done the Sech x graph here previously in the previous section. Okay, so let's exchange and get the Sech inverse. Y equal r Sech x. So I'm gonna change the x and y coordinates. Okay, guys. So here the y coordinates are going to become the new x coordinates. Okay, and the x coordinates are the new y coordinates. Okay, so let's draw the graph now for r Sech x. Right, guys, can you see? So this is the graph. Okay, but so I think I told you guys that we need to restrict the domain, right? So this it can't be the case. We need to restrict the domain. So for the r Sech x graph, okay, for the r Sech x graph, we don't consider the negative x values, right, guys? So this section needs to be removed. Are you with me? So we don't take this part of the graph. We're only taking the other part. So let me remove this section from this part. All right, guys, I'll remove this. Right, guys, so this is it. So this is the part of the graph you have for R section. Okay. So this is y equal R section. Can you see, guys, the shape? So you can see the peak is around, I mean, the peak over here, and it comes making the kind of like the bell shape here, right? So then you can draw the shape now. So the peak one comes over here, and you need to draw that into comes over here. So you draw it like this. All right, guys, the full graph would have looked like this, but we removed this part, right? So this is the R Sech x graph. Are you with me? So this is the R Sech x graph, and then you can discuss the domain. The domain of the R Sech x graph, clearly the x values you can see. X values are greater than 0, less than or equal 1. Right, guys, are you with me? So R Sech x. Okay, x values are, x values should be greater than 0 and less than 1. All right, and your range, you can see your y values are greater than or equal to 0. All right, guys, so this is all you need to know about the Sech x graph, right? I hope it's all clear with you all. So now let's go for the R Sech graph is done. So let's go for the R cos H x, okay? So in order to draw the R cos H x graph, so let's first take a look at the cos H x graph. So we have done the cos H x graph, right, guys? We discussed the properties. So it was basically looking like a 1 over x graph, right, guys? So this was our cos H x graph. So now let's see how to draw the inverse. Okay, so cos H x. So y equal cos H x. We want to draw y equal r cos H x. Right, guys? Okay, so we already have the graph of cos H x. Right, guys? Okay, so we have already got the cos H x graph over here. And the first thing, as I told you guys previously, is that you need to check whether the original graph is 1 to 1 or whether it's many to 1. Because if it is many to 1, then you have to restrict the domain to make it 1 to 1. So when you look at this cos x graph, guys, you can clearly see it's a 1 to 1 graph. We don't have any trouble here, right? There's no trouble here. So cos x is directly a 1 to 1 graph. So we can directly take the entire domain and range and we can flip it, right? So shall we do that? So I already calculated the Cossack's graph previously, right? So I have it here. So now let's go for y equal r cos hx. Okay, so xy coordinates are going to flip. So you paste the values here. All right, so now let's draw the graph. All right, guys, so this is the r cos hx graph. You can see it's almost, there is a little bit of similarity, right? But there are slight differences. Okay, so maybe you can see them if you draw them together in this case. I guess so you can see this is okay, so it's when you draw both of them together, so you can kind of like see how the differences go because the points you can see some points they rapidly increase, so it's a tough thing to draw them both in one graph, but you can see the difference, right, guys? So this is clear. This is how you I mean you can see how both graphs look when they are drawn on the same axis. Okay, so all right, guys, I think yeah. So they've done that. Okay, so basically, there's not much of a big difference. Okay, when you exchange, I mean, when you draw the graph. Okay, so you can see here the Cossack graph. You can see the asymptote. I mean, it's just a slight difference, right, guys? So you can't show much of a big difference. Okay. Okay, so when I draw the inverse, you really can't show a big difference here, right? So they look almost the same. Okay. The asymptotes, the domain and range, I think you can see that you don't have much of issue, so many issues here, right? Because your x-axis and y-axis were asymptotes. So when you interchange, again, I mean, the x becomes y becomes x, but you already have both of the original x and y-axis as asymptotes. So they both will still remain as asymptotes, even though they interchange. You can't see much of a big difference here, guys. Okay, so this is what the Cossack and our Cossack graph looks like. So basically, the only thing is from the domain. So you can see that Cossack graph, your domain has all the real x values except 0. You don't have 0, right? Because you can see that x equals 0 is an asymptote. And your range also, guys, you can see here, your y has all the real values except y0, because y0 is again an asymptote. Basically, in the R Cossack graph here, your domain is again, you exchange. So basically, you have this y becomes the x, but it's going to be the same. Right, guys? Because this comes over here. So the y changes to x. And the range, the domain here becomes the range. All right, guys. That's it. So this is what you have over here. All right. Okay. So now let's move on to the final graph. Right. So final graph we have discussed R cortex. Okay. So let's see how that's done. Okay. So R cortex we already have discussed the cortex graph, right, guys? We have discussed the cortex graph, and you can see we have discussed what happens when x reaches positive infinity, negative infinity, and the zero. So you saw the cortex graph is always greater than, I mean, y values are greater than 1 and smaller than -1, right, guys? So these were the things we learned about the cortex graph. So now let's see what happens when we go for the inverse, right? So I'll use the help of Excel here. So we've already drawn the cortex graph, here, right, guys? All right. So first thing here is one look at the graph, and I told you first to check whether it's one to one. So one look at the graph, and you can clearly see it's one to one, right? Guys, you don't have many x values leading to one y value. One x leads to one y, so you don't have any problem here. So we can go for the R cortex here without any issue. So y equal R cortex. So just exchange x y. Okay, so y values become the x values now. And the x values become the y values. All right, so let's draw the R cortex graph and see how it looks like when you exchange x and y. Right, guys, I think you can see clearly I hope you guys can see what's happening now. So can you all see what's going on here? So when x and y interchange, guys, now I showed you in the previous step that, so we saw that, okay, so let me show you here. You saw that over here, the y-axis were the asymptote, y equal 1 and y equal -1 were the asymptotes, right, guys? So in between 1 and -1, you didn't have anything else. So now when you exchange x and y, you know that y equal 1 asymptote should become x equal 1. Y equal -1 asymptote becomes x equal -1. So I think you can see it over here. Can you see, guys, over here on the graph? X equal -1 and x equal +1 are the asymptotes. Right, guys? And the entire graph has just flipped. Okay, so that's it. So it's not difficult here, right, guys? So now you have the empty space between x equal 1 and -1, and you just flip the graph. Okay, so when I draw the y equal R cortex graph, okay, when I draw the y equal R cortex, right, guys, the y equal 1 and -1 now becomes x equal 1 and x equal -1. All right, guys. So between these two x equal 1 and -1, you don't have any space. There's a blank empty space. Okay, and the rest of the graph should go like this, right? All right, guys. So that's it. This is your graph. So you can see that this is what we have over here. All right, guys. So this is the R cortex graph. So we'll discuss about the domain and the range. So the domain, clearly, what do you have for the domain? You can clearly see that the x values are greater than +1 and it's smaller than -1, right, guys? Are you with me? Okay, so here you can see, yeah. So in R cortex, they have given the domain modulus x is greater than 1. Makes sense, right? Do you see it makes sense? Because over here you can see your domain x values are greater than 1 or your x values are smaller than -1. So another way of saying this is that modulus x is greater than 1. Okay, because the modulus is the magnitude and it should be bigger than 1. Okay, so another way of saying it. Right, guys, and your range. I think you can see y values. You have pretty much all the y values except the asymptote y0. Okay, except y0, you have all the other y values. All right, guys. So this is the domain and the range. So I think this part is. I hope this part is clear with everyone. Right, guys. So we discussed all the 6 inverse hyperbolic graphs.